Hi, welcome to our last lesson for Unit 3. But before we go into that, we're going to review Lesson 4A, which was graph and direct variation. You learned that a direct variation will be in the form of y equals k times x, where k is not equal to 0. K is called the constant of variation, and the y changes directly with x. And what makes direct variation equation different from other linear equation is that it passes through the point 0, 0. Every direct variation equation always goes through the origin. To graph it, you also learn how to graph it. You graph it by writing the slope as a rise over run. So if you had 5, you turn it to 5 over 1, or if it's a fraction. Then you graph the point first, 0, 0. Then with your slope, you either go either opposite direction to find your other points. Then you plot you have your points plotted. You connect the connect the points by drawing a line, and then of course your arrows, and label your line. All right. So today's topic is direct variation. We learned how to graph direct variation equations. Now we're going to learn how to write direct variation equations. So the objective is, how do we write direct variation equations? Alright, so to write a direct variation equation, you use the first comparison to solve for k. So we're going to do this with the examples, but listen, oh my god, let's try again. Listen to how the steps are used in order to solve this. You first compare it by solving for k. Do the first comparison by solving for k. Then you substitute the k value to solve for the missing x or y in another comparison. That means in another direct variation equation. Then you write the direct variation equation in the form of y equals kx. And in this situation, you would just use what you've found for k. So now, write a direct variation equation for the following scenarios. We got an example. It says y varies directly as x, and y equals 28 when x equals 7. So the first thing you do, you would find k. So you use what they gave you. You find k. So see the work here. You found that 4 is equal to k. Now once you did that, step 2, you plug k value into the direct variation equation. So all you just do is, when you found k, you just put it into the equation, and based on what you found for k. That one is just simple as is. They just want you to create a direct variation equation, but you have to find k. Now, we're going to use that example, but then we're going to try to use the first example that we saw, but then use that k to find either x or y. In this case, we have to find x. So we're going to, first, I'm going to write y equals kx. They said that y equals to 28, and then x equals 7. So that means I need to find k. I'm going to plug in my information. Now I have to solve for k. I'm going to divide 7 on both sides. And then I got my k as 4. So now that I found my k as 4, I'm going to rewrite the equation. And now for the second part. So this is my first part. Now this one is my, put over here, second part. So this is the first, and then this is the second part that I'm doing. So using that equation, direct variation equation, I need to find x when they gave me y. I already have my k, so I'm going to plug that in. My y is 52, so I'm basically just substituting, and now I can solve for solve for x. So when I divide that, my answer will give me 13. So my x will equal 13. So that's what I had to solve. Right. That's That's using the direct variation equation. Now, they also do that for d equals RT. So d is the distance, t is time, r is rate. And then the distance varies directly as time, and the rate is a constant variation. So you know, if you know y equals mx, you got that m, which is your slope. You got y equals kx, that k is your slope. Your r is your slope, it's that rate. The constant, it's the constant of variation. Notice where the location is, and that tells you that, okay, I need to do something with that, find something, find this, in order to plug it back into this equation to find what they want me to find. Same thing as we did with y equals kx. So, here, as I explained, you're using that formula. Notice where the k is, but instead of using this, you're using the distance formula, and where your r is the same as k, and your r is your constant rate. So we got an example. I'm going to expand this so I can go down here. It says Darrell and Denham took a road trip to Disney World. Lots of D's in this sentence. They traveled 375 miles in 7.5 hours. Identify the variables and write the direct variation equation. Notice how I highlighted that because that's what we're working with, using the distance formula. So we're going to plug in the information that they gave us. They traveled 375 miles, so that's the distance. And then they did that in 7.5 hours. That's the time. Then they want us to find, we have to find the rate. So now I'm going to do d equals r times t. I'm going to plug in the information that they gave me, and then I'm going to solve for r. That's giving me the constant rate, the constant variation. So my r will equal, so if I plug that into the calculator, gives me 50. And now I need to write a direct variation equation using what I found. So it will be d equals 50t. They just want me to they want me to give the equation. Because if you just stop at r equals 50, then that's not what they were asking you for. They want you to write an equation. So pay attention to what they're asking you for and how to set it up. Alright, next one. Darrell and Denham had so much fun, they decided to take another road trip to Disneyland. If they travel the same rate as they did to Disney World, how long will it take them to get to Disneyland, which is 300 miles away? So we're using that formula. So we're using d equals RT. We know that the distance is 300 miles. And then, let's see, they said that if they travel at the same rate as they did to Disney World. So let's go back. The rate was 50. As I scroll it down, the rate was 50. So we're going to use 50 for this problem. And then they want to know how long. That's time, how long. So now we need to find just the time. That's it. So this will cancel out, and your t is 60, and then what did they use? They didn't use any time or anything, any units. So let's see what I got here. 60 hours. Yeah, so 60 hours. We found your t to be 60. Right. Let's go on to the next one. Now, when they give us something like this and it's based on direct variation, we're doing a two-parter. This is the first part, this is the second part. So the first part, They gave me y and x. So I'm going to use that formula, y equals kx, plug in the information to find my k. So we divide, cancel, k is equal to 2. Now the second part, we're going to use that k back into that equation and then find y. So then y equals 2 times 5, so 10, y equals 10. And when you deal with direct variation, you're always going to do a two-part work. Okay, same thing with this one. I'm going to break it down because that way you get into the habit of knowing that, oh, direct variation, 2 steps to this work. So I'm going to put y equals kx, y equals kx. They give me y and x. I'm going to find my k. I'm going to divide on both sides. My k is 6. Then I'm going to plug it back in here. Oops. Y is 42. Let me do that better. It's horrible. It looks like 0 trying to be a 2. So 42 equals what I found for k. And divide, and that's going to give me 7 for my x. So put in all the information you need, know what you're doing, and solve what they're asking you to solve for. Okay, same thing. You got to get used to that one, especially when dealing with direct variation. So I'm just going to write that for both, so that I know that I have to do this twice. This one I have to find k. Divide 4. I got a negative number going on here, so it's going to be a negative answer. And then my y is 20 that they gave me. I found my x, which is negative 4. My k, which is negative 4, and now I need to find x. And I divide. That's going to give me negative 5. And I forgot to unveil the answer for the other one. Let me do that. 7. And this one is negative 5. Alright. Answers, same thing. Towards the end of this lesson, there are word problems. So if you get the gist of this, then you can move on to the section where the word problems are. If you still need more practice, just stick around and we'll get to the end. So that negative 18, we're solving for k. What? I always switch those two. So silly. Solving for k. We're going to cancel that, and it gives us negative 3. Plug it back here. We have y. We have our k. We need to find our x. And we're going to divide negative 3 on both sides, and we get negative 2. Alright, next one. And 2 parts. First part, second part. Y equals kx. First thing we do, we need to find the k. And even if I say it, try to think of it first before I say it, it still messes up. K. Find the k. First, that you can leave as 4 over 12, or you can reduce that, so that'll be 1 over 3. Then you plug it back in, we're finding y. And we'll have the x as negative 24. So you multiply that, that gives us negative 8. And we found our y. Okay, more of the same thing with this. Like I said, if you got the hang of this, then you can move on to the, I think, last 2 slides where there are word problems based on using direct variation equation. So this, same thing, y equals kx, y is 12, Look for our k, and our x is 15. We're going to divide that. So in that one you can reduce. If you have 12 over 15, you can reduce that to 4 over 5. Oops, 4 over 5. Our y is 21. K, 5 over 4. Then we're looking for our x. And remember, when you're dealing with fractions, you're going to do the reciprocal on both sides. So you don't have to worry about dividing fractions and then flip, switch, keep, switch, and flip. So this one will cancel out. You'll be left with x on this side, and then you just multiply straight across. If there's anything you can reduce, if not, multiply straight across. So you're going to have 105 over 4, and I don't think that can be reduced. I'm going to check. Nope, that's our answer for that one. Or you can turn it into a mixed fraction, or you can, let's see if it can do a decimal. It gives you a nice number. Yeah, you can turn it into a decimal. This one gives you 26.25. Or 26.25. Okay, so this is more of the same. If you get this, then the same thing, especially with fractions. Alright, so let's go on to the last two word problems with dealing with direct variation. So we have Denise and Kayla go on vacation to Paris. The trip, they fly the 555-mile trip in 5 hours. If they fly the same rate, how long will it take them to fly to Barcelona, which is 600 miles away? So again, we're using the D equals RT. So I know it's going to be a two-step, so I'm going to do that twice. So we have the mileage for the first one and 5 hours. So we need to find the rate. So we got 555 equals R times 5. We're going to divide the 5. So that will give us 111. We're going to use that and then find out how long it will take them to fly to Barcelona, which is 600 miles away, using that same rate. So we plug in the R, which was 111, times T, and solve for T. T equals, we got 600 divided by, oops, I put the wrong number, 600 divided by 111, which will give us 5.405. But since we're dealing with hours, we need to convert this portion into hours. So when you do that, this basically you have to do, I don't know if I have to round that off. Actually, yeah, you would have to, this would be your hour. Let me unveil this one. It would be an hour, 4.5 hour, so I'm not going to put all those numbers. And then this will turn into 24 minutes, because think of, this is 0.4 of an hour. And in order to find that, let me get clean. So you would have to convert that. And you know, 1 hour, how many minutes are in there? 60 minutes. So you have to do the conversion to find your minutes. Because if they ask you for time, you need to turn it into that. But if you want to leave it in hours, you could leave it as 5.4 hours. But don't put all these other numbers after it. Alright, the next one. So it says it took Mumi 1.6 hours to drive to her grandmother's house, which is 112 miles away. She would like to go shopping for Christmas gifts at an outlet that are past her grandmother's house. If she drove at the same rate, how many hours would it take her to drive the 210 miles to the outlets? So let's look at the information. We have the time, we have the distance, they want to know the same rate. We don't know what the rate is. And then this one asking you how many hours using this mile. So it's going to be a two-parter, and we're using D equals RT. So the first one, we got the distance, we need to find the rate, and we got the hour. So then that gives us 70. Yep, 70. So now we're going to use that same rate, and then based on how many based on her driving to the outlets. So we divide. This cancels out. Be 3 hours. All right. So we reached the end, and as a recap, we learned about writing direct variation equations. So basically, we know K is replacing the slope. That represents the rate. And then if they tell you it's a direct variation equation that you have to write, they will give you the y and the x, and you need to find the k. Once you do that, then you write it as y equals k, whatever you found for k, and then x. Don't just leave it as, oh, I just found k and that's it, because there's a two-step problem. And then there's other questions where they'll give you one part where you find the k, and then they're going to give you an x or a y, and then you have to use that k to find the missing variable that they're asking you for. So be careful. You always have to read what they ask you for, and then figure out how to set it up and then solve it. Then we learned about using the distance formula. It follows the same procedure as the direct variation formula. It's the same thing, but you're using distance, and r is the constant rate. So again, just like you did with the y equals kx, you're doing that for d equals rt, where you have to find the rate, and then you use that rate. Well, for this one, this is for k. Let me go back to the word problems. So you use that rate to find whatever they're asking you for, whether it's the distance or the time. All right, so during this lesson, if you have any questions, if there was anything confusing, please email me, so that way you get better clarification, and then you can be able to do your homework or activity or whatever is assigned with this lesson. All right, so this ends our lesson, and have a good day. And